Hello. This particular lesson is going to be much shorter than the last. It's kind of an extension off of what we did. As you can see up at the top, it's 6.4b. What we just did was 6.4. It's kind of just taking what we did last time and bringing it to a bigger or a higher level. So what we need to do first is take a look at, to solve exponential equations, do what is necessary to make the bases similar. We want the bases to be the same. Right? And we'll see that as we go through some examples. Once the bases are the same, you can set the exponents equal to each other. Alright, so let's see how that works. In A, I have 5 raised to the x equals 125. Now, technically, what this says to me is 5 to the x equals 125 to the first. Now, if the first step for me is to make the bases the same, what sort of way can I rewrite 125 so that it has the same base as the left side of the equation, which in this case is a 5? Let's take a look. I have 5 to the x equals, and how can I represent 125 but with a base of 5? Well, this is a particular example we've seen a couple times already, so hopefully you're getting better at recognizing that the cubed root of 125 is 5. So I can represent 125 as 5 to the third. Okay, now I have the same bases, which tells me that 5 to the x should equal 5 to the third. Well, it almost might be really intuitive to say, well, if this side says 5 to the third, this is 5 to the something. In order for it to be equal, that must be a 3. And in fact, if we have similar bases, I can go and just take the exponents of each side and set them equal to each other. In this case, it's simple, because we just get our solution, x equals 3. In other cases, it might not be. Let's take a look at a case like that in B. Here I have 4 to the x equals 2 to the x minus 3. So first of all, I need to try and get the bases the same. Okay? So let's see. 2 raised to the x minus 3. 2 is already a very low base. It's a prime number. There's nothing I can really do to change that one. Over here on the left side, though, 4. I do know that I can change 4 to be represented in a way that it will have a base of 2. Right? I can say 2 squared. Right? So over on the left side, I have 2 squared, that's my 4, and that 4 is raised to the x power. Now what happens when I have a power raised to a power? Well, we need to think about our exponent rules. Power to a power means I'm multiplying them. So this is 2 raised to the 2x equals 2 raised to the x minus 3. Now see, we got to this same point where I have similar bases on the last example. I have similar bases on this example. So what I can do is set the exponents equal to each other. Now it's not as simple as an intuitive as this last one, where it just said x equals 3, but it still won't be too difficult. I can set the exponents on this side, 2x, equal to the exponents on this side, x minus 3. And now I have a much simpler algebraic equation that I can solve for. I subtract x on this side, and from the other side. 2x minus an x gets me 1x, and it's equal to what's left over here, negative 3. Now we're going to go to C. C is going to be very much like B and very much like A, but again, it's going to be slightly more complicated because of the fact that we have more complicated exponents. So let's rewrite. 9 raised to the x plus 2 equals 27 raised to the x. Now, is there a way that we can write these two things with similar bases? In the first one, I had to rewrite just the right side. In the second one, I had to rewrite just the left side, but then I had some exponent stuff to deal with afterwards. In this example, we're going to have to rewrite both sides. Okay? I can write 9 as 3 squared. I can write 27 as 3 cubed. Okay, so now I have similar bases. So this is my 9, and 9 was being raised to the x plus 2. And this is my 27, represented as 3 cubed, still being raised to the x. Now, again, we need to look at, I have a power raised to a power. Now this, be very, very careful here, because it's 2 multiplied by x plus 2. Technically, that's distribution. I need to be sure that when I multiply these, I do 2 times x and 2 times 2. So this is going to be 3 raised to the 2x plus 4 equals 3, again, multiplication, raised to the 3x. What's my next step? Yes, I have similar bases, so I can set the exponents equal to each other. I'm going to do it off over here because I've run out of room. But it's the exponents on the left side, 2x plus 4, equal to the exponents on the right side, 3x. Now I have a small, simple algebraic equation I can solve for x. All I have to do, subtract 2x, get like terms together on one side of the equation, and I get 4 equals x. And my equation is solved. For all of these, a, b, and c, if I take my x and I plug it back in, the answer will be true. 5 to the third equals 125. Yes, that's true. Over here, 4 to the negative third equals 2 to the negative third minus 3. Yes, that's true. Over here, I have x. 9 raised to the 4 plus 2 equals 27 to the fourth. Absolutely. Remember, you can always check your solutions that way by taking your solution, plugging it back into the original. Try the practice problems at the bottom, and we'll talk about it again in class.